Welcome to the AI Coach by Anil Nathu. For years, we've watched AI evolve, right? From something in sci-fi movies to, well, something we interact with almost daily.
Absolutely. It's been quite the journey.
But what's coming next? It feels like a really profound shift. We're talking about agentic AI.
That's right. It's a whole new ballgame, really.
So today, we're taking a deep dive into the Infosys Agentic AI Playbook. It's this fantastic guide, super comprehensive, on understanding, building, and crucially, deploying these powerful, self-sufficient AI systems responsibly. Our mission here is pretty straightforward. We want to pull out the most important insights from this expert source. We want to give you, our listener, a really clear understanding of what agentic AI actually is, why it's so transformative, how you build it, and the critical things to think about for adopting it responsibly.
Yeah, consider it your shortcut to getting up to speed on this really cutting-edge topic.
Exactly.
Because, while many folks are still getting their heads around generative AI, which is mostly about enhancing efficiency.
Right, making things faster or easier.
Agentic AI, as this Infosys playbook really emphasizes, it's about reinvention. Full stop.
Reinvention, okay, that's a strong word.
It is. Think back to the shift, decades ago. Businesses didn't just digitize their paper forms, right? The smart ones completely re-engineered their processes for a digital-first world.
Ah, okay, so it's that level of change.
Precisely. Agentic AI isn't just adding a bit more automation. It fundamentally redesigns how systems operate by baking these advanced cognitive abilities right into the core of the business. It's about creating truly AI-native systems built around AI from the get-go.
Got it. Not just a bolt-on.
Not at all. The next evolution. What is agentic AI?
Okay, so let's start this journey then. Let's set the stage for how AI has evolved to this point. We've seen it match or even beat human abilities in areas like, well, image recognition, even complex stuff like algorithm design.
Yeah, the progress has been staggering.
But this next leap, it happens when AI gets the ability to actually reason, to coordinate complex tasks, and crucially, to act with purpose. That's when it stops being just a tool and becomes an agent.
The ability to act autonomously is key.
And this isn't some far-off future thing, is it? The playbook points out it's accelerating really fast. Gartner apparently sees agentic AI as a top tech trend for 2025.
Right, and Deloitte predicts that by 2025, something like a quarter of companies already using generative AI will be kicking off agentic AI pilots or proofs of concept.
Wow, a quarter. So it really is just around the corner.
It is indeed. And at its heart, an AI agent works on a pretty foundational concept. We call it the sense plan act cycle.
Stimulus plan act, okay.
It's quite intuitive, really. An agent observes its environment. Think of it using sensors, digital or physical. Then it processes that input, figures out what's going on. That's the plan part.
Right.
And finally, it uses actuators, again, could be mechanical arms or just digital commands, to actually change its environment and achieve specific goals.
Okay, that makes sense. Observe, think, do.
Exactly. But what's truly revolutionary now is how large language models, LLMs, are becoming these incredibly sophisticated brains behind the agents.
Ah, so the LLMs are driving the plan part.
Increasingly, yes. They allow agents to orchestrate these LLMs as needed, leading to highly structured, task-driven interactions that all align with the system's overall goals. It's a huge leap in capability.
Okay, I see. And the Infosys playbook, gives us a really helpful way to visualize this whole evolution, right? Through these tiers of AI agents.
Yes, that's a great framework. It shows the progression really clearly.
Let's walk through those because it really shows how we get from simple automation to, well, almost complete autonomy.
Sounds good.
So tier 0. Simple automation. This is basic stuff, right? Rules-based, like a script checking if a sensor reading is within a certain range. No real intelligence.
Correct. Deterministic. Then you have Tier 1, robotic process automation, RPA. This is a step up, maybe automating a whole segment of a process, like scraping data from screens or filling forms. Still rules-based, mostly. Still pretty rigid, yeah.
Exactly. Then Tier 2, elementary AI augmentation. This is where agentic AI starts to make its first real appearance. It uses language models for, basic intelligent interactions.
Okay, like what?
Think about agents classifying support tickets, reading the text, understanding the sentiment maybe, and routing it to billing or tech support, or maybe automatically labeling data based on its content.
Got it. So adding a layer of understanding.
Right. Now, Tier 3, AI agent twins. These act like, well, digital twins for users. They interpret your intent and can autonomously take action.
Okay, examples.
Well-known ones the playbook mentions are GitHub Copilot, suggesting code as you type,
Use that all the time.
Or Microsoft 365 Copilot, drafting emails, summarizing docs based on your prompts. They're intelligently deciding how to help.
Right, making decisions. Okay.
Then we get to Tier 4. Refined AI agents with reflection. This is a more advanced class. A lot of organizations are really keen on this tier. These agents can break down complex goals into steps, formulate plans, and analyze their own results. Reflection. So they can learn from mistakes.
Exactly. They can adapt their approach if something doesn't work. A great example the playbook uses is a credit decision-making system. An agent could process a loan application, automatically extract data from bank statements, analyze it for accuracy, check it against lending regulations,
Wow.
and flag discrepancies, or even make an initial recommendation, all while learning and refining its process.
That's pretty powerful.
It is. And finally, Tier 5, complete autonomy. Think AGI, artificial general intelligence, or even ASI, superintelligence. This is still, mostly future-gazing. Optimistic predictions put it maybe 2026 to 2029, but who knows?
Right.
These would be agents capable of original research, independent reasoning, developing genuinely novel solutions way beyond their training data, continuously learning, acquiring new skills autonomously.
Like the AI designing a new vaccine example. That's mind-blowing.
It is. That's the ultimate potential in it.
Okay. So to make all this happen, especially those higher tiers, you need a pretty sophisticated architecture underneath.
You absolutely do. Understanding that blueprint is key. It really starts, as you might expect, with a user input or event trigger. That's just the prompt, right? Your query or maybe a data feed changing that kicks the agent into action.
Okay, the starting signal.
Then at the core, there's a goal-based orchestration engine. Think of it as the conductor making sure everything the agent does aligns with the overall objective.
Keeping it on track.
Exactly. And then the big one, the planning module. This is really the agent's brain. It's got several crucial parts inside it.
Okay, break that down for us.
Sure. There's a reasoning layer. This uses algorithms to analyze the inputs, figure out a strategy, break down big tasks into smaller subtasks. It also, importantly, refines prompts it sends to LLMs and might use things like knowledge graphs for more precise context.
So it's doing the thinking and strategy.
Right. Then you have tools and skills. These are like pre-built software modules the agent can call on. Things like document digitization, OCR, maybe generating a PDF. It's how the agent interacts with other systems or data formats.
Kids have practical abilities.
Exactly. Then memory. This is absolutely vital. It keeps track of the current conversation, past interactions, which tools were used, what worked, what didn't. It allows for context-aware planning. For something sophisticated, like an AI coach by Anil Nathu, this memory is essential for providing truly personalized, continuous guidance over time. It needs to remember your goals, your progress.
Makes sense. Context is everything.
Totally. There's also an integration module, usually using APIs, to connect to the outside world databases, external services, you name it.
Connects it to the wider world.
And, crucially, the human in the loop. This is the safeguard. A point where a human needs to approve a critical decision, especially in high-stakes situations. You don't want full autonomy everywhere.
Well, that oversight is key.
Definitely. Powering all this is, of course, a language model, the central decision maker, using reasoning frameworks like React or Chain of Thought. And sitting underneath or alongside all of this is security and compliance, ensuring data privacy, ethical standards, all that crucial stuff.
Non-negotiable.
Absolutely. And finally, an evaluation layer constantly measures how effective the agent is, feeding back insights to the planning module so it can improve over time.
So it's a continuous loop. Sense, plan, act, evaluate, reflect.
Exactly. That constant cycle is what gives these agentic systems their high degree of autonomy and adaptability.
Okay, that paints a very clear picture of the how. So back to the why. Why do businesses need this? What problems does agentic AI solve that maybe current automation or even Gen AI doesn't quite hit?
That's a great question. The Infosys Playbook points to 3 really compelling reasons why organizations need to be looking at this. First, operational efficiency. Agentic AI isn't just about automating single tasks. It can integrate across different tools, APIs, and departments to spot inefficiencies in complex end-to-end processes and then autonomously implement improvements.
So it doesn't just find the problem, it fixes it.
Potentially, yes. It ensures process agility in a way static automation can't. Second, the ability to scale rapidly. Think about traditional systems. Often, if the workload doubles, you need double the staff or double the resources.
All right, linear scaling.
The agentic AI can break that link. Because these systems can self-optimize and manage tasks intelligently, they can enhance capabilities and handle much larger volumes without necessarily needing a proportional increase in staffing.
That's a huge advantage.
Huge. And third, dynamic problem solving. This is key. Traditional automation needs predefined rules for everything. Agentic AI, through contextual reasoning and learning, can manage unstructured tasks. It can generate intelligent responses to complex, ambiguous requests without needing explicit instructions for every single possibility.
So it can handle the messy real-world stuff.
Exactly. Problems that would completely stump traditional automation.
Okay. But it's not the right tool for every problem, presumably.
Definitely not. And that's where the Playbook's SCOPE framework comes in handy. It's a really practical way to assess if agentic AI is a good fit.
Scope. What does that stand for?
It helps you evaluate 5 key areas. Strategic alignment. Does this opportunity really align with your long-term goals? Is the current workflow heavily manual, complex, and ripe for genuine transformation?
Okay, is it strategically important?
Right. Complexity of task. Is the task itself planning intensive? Does it involve multiple steps? Maybe is deterministic, but the number of rules needed would just grow exponentially, making traditional automation impractical.
So, inherently complex tasks.
Yes. Operational environment. Does the task need real-time action? Does it need to adapt dynamically to changing conditions? Does it involve pulling data from lots of different streams?
Needs to handle dynamic environment.
Exactly. Performance requirements. Are there strict needs around speed, latency, cost reduction, or accuracy that an agent could meet better than current methods?
Performance games or a driver.
And finally, ethical and security constraints. This is crucial. Can the agent's actions be properly governed, monitored, and controlled? Are there significant ethical risks associated with autonomous decisions that need really robust safeguards?
Right. Got to think through the risks.
Absolutely. Using Scope helps you pinpoint those high-impact, suitable use cases where agentic AI can really shine.
That's super helpful. Okay, let's make this even more concrete. The playbook has some fantastic real-world examples. Let's talk through a few of those.
Yeah, they really bring it to life.
In financial services, there's Combank in Australia. They're using agentic AI to process something like 15,000 payment disputes every day.
Wow.
Customers can just describe their issue in natural language, and the AI figures out if they're eligible, verifies the details, and lodges the dispute automatically. Think of the manual effort that saves.
Incredible efficiency gain. And HSBC, another example, built a system called NOLA 2.0 using agentic AI for credit risk management. It helps them adapt to changing regulations like Basel III and optimize capital allocation in real time.
Okay, so complex regulatory stuff too. What about other industries? High tech.
Waymo's driverless cars are a classic example. They use agentic AI constantly to analyze sensor data, LiDAR, cameras, radar to perceive the world, plan routes, and react instantly to unexpected things like pedestrians or debris, ensuring safety and efficiency.
Right, autonomous driving is a prime example. How about logistics and supply chain? I know that's a hot area.
Huge potential there. The playbook mentions Pando.ai. During the Panama Canal drought in 2024, their agentic AI system rerouted over 5,000 shipping containers.
5,000, wow.
Yeah, autonomously identifying and executing alternative shipping paths, avoiding an estimated $12 million in delays. That's massive
I
impact.
don't believe that.
And Levi Strauss, the clothing company, uses agentic AI for really granular demand forecasting. It analyzes real-time sales data, social media trends, all sorts of signals, and then autonomously adjusts inventory levels across different stores and regions.
Getting the right jeans to the right place at the right time.
Basically, yeah. Avoiding stockouts and overstocking.
Okay, manufacturing.
Siemens developed a multi-agent system to optimize complex engineering workflows. They have different agents playing roles like system architect or requirements engineer, collaborating to design products more efficiently.
Agents working as a team. Cool. And finally, telecom.
Telenor deployed conversational agents to handle customer queries. These weren't just chatbots. They could autonomously resolve issues. The result, a 20% jump in customer satisfaction and 15% revenue growth in the first year.
Those are serious numbers.
Absolutely. And TalkDesk uses similar tech for retail customer service, managing complex things like order updates, handling returns, providing hyper-personalized support 24/7.
Okay, these examples really hammer home the point.
They really do. They underscore the playbook's main conclusion. Agentic AI is a defining moment. It's self-directed, it's adaptive, it's deeply contextual. It's not just incremental improvement, it's redefining how technology engages with the world. AI is becoming a thinking entity, a collaborator.
A collaborator. I like that framing. It's capable of navigating complexity, optimizing processes, and just unlocking vast new possibilities everywhere.
Exactly. It's a fundamental shift.
Huh.
Just great. The core mechanics, architecture, and agent types.
Okay, so we firmly established the what and the why. People should be convinced of the potential now. Let's peel back another layer, get into the core mechanics of how these agentic AI systems are actually built.
Right. Let's get into the weeds a bit.
The Infosys Playbook really stresses that for business leaders, understanding these nuts and bolts, the different agent types, the architecture layers, the tools, is not just for the techies. It's a strategic imperative.
Absolutely. Making informed decisions about where to invest, how to build, how to gain that competitive advantage relies on understanding this stuff.
Okay, so at the heart of it all is that sense, plan, act cycle we talked about.
Yes, that's the foundation. But to really get the most out of it, you need to pick the right type of agent for the job at hand. Different tasks need different levels of sophistication.
Makes sense. So what are the main types the playbook breaks down?
Okay, let's run through them. First, you have reflex-based agents. These are the simplest. Think predefined rules or reflexes. If X happens, do Y. No complex reasoning.
Like the sensor check example earlier.
Yeah, exactly. Intel uses them in chip manufacturing, the playbook notes. Cameras see a defect based on rules, the agent instantly flags it. Simple, fast, accept, reject.
Okay, basic but effective for specific things.
Right. Then model-based reflex agents, these are a step up. They maintain an internal model of the world, tracking changes. So they make decisions based on reflexes and their internal understanding of the current state and maybe past experiences.
Okay, so they have some memory or context.
Yes. The example given is a smart irrigation system like Ruckio. It doesn't just react to rain, it integrates weather forecasts, knows your soil type, learns local patterns, and predicts the best watering schedule. It has a model of its environment.
Much smarter. Got it.
Then goal-based agents, these combine that internal world model with a specific, defined goal. Before they act, they actually plan sequences of actions to achieve that objective.
So they're actively planning towards a goal.
Exactly. Amazon's Kiva robots in their warehouses are a classic example. Their goal is order fulfillment. They plan efficient routes to pick items, coordinating with hundreds of other robots to avoid traffic jams and get orders out fast.
Okay. Planning and coordination.
Next, utility-based agents. These agents try to maximize some measure of utility or reward. They select the action sequence that gives the best expected outcome based on defined criteria, maybe balancing risk and return or cost and speed.
Optimizing for the best outcome.
Precisely. BlackRock's Aladdin platform for investment management is mentioned. It uses utility-based agents to optimize portfolios, balancing complex factors to meet specific investment goals.
Makes sense for finance.
Then there are object-centric or curious agents. These focus on understanding and interacting with individual objects within their environment, rather than just the overall scene. They prioritize getting detailed info about specific things and their relationships.
Okay, why is that useful?
Think healthcare. Artery's AI platform in radiology uses these. The agent actively analyzes specific features within medical images, tumors, fractures, learning detailed patterns from individual cases across X-rays, MRIs, CT scans to improve diagnostic accuracy over time. It focuses on the objects of interest.
Ah, I see. Detailed analysis of specifics.
Right. And finally, citizen-centric autonomous agents. These are the kinds of agents that might manage routine personal or professional tasks for us. They use advanced AI to understand your objective, break it down, and execute workflows across different apps autonomously.
Like a personal digital assistant on steroids?
Kind of, yeah. Examples include OpenAI's operator agent managing email sorting or making online purchases by interacting with websites.
Oh, wow.
Google's Agent Space automating things like pulling data from PDF invoices, or Anthropic's Claude Computer Cart use performing tasks directly on your desktop. These tools really embody that vision of personalized assistance, like an AI coach by Anil Nathu, helping manage your digital life or work tasks.
That sounds incredibly useful.
Yeah.
Okay, so those are the types. When you're actually building a system, you also have to decide between a single agent or multiple agents working together, right?
Yes, that's a key architectural choice. A single agent might be fine for clear, self-contained tasks, but for complex problems that need collaboration, different skills, or parallel processing, a multi-agent system is usually the way to go.
And the playbook focuses more on multi-agent.
It does, because that's where a lot of the complex enterprise value lies. But it also brings challenges. You have these dynamic, adaptive AI agents trying to work within enterprise systems that are often designed to be very deterministic and rule-bound.
Yeah, how do you balance that?
Mhm.
The AI wants to be flexible, the enterprise system wants predictability.
Exactly. Finding that balance, ensuring consistency and reliable outcomes while still leveraging the AI's adaptability, that's a core design challenge.
Hmm. Okay, let's talk about the architectural layers themselves. You mentioned core layers and standard layers.
Right. Think of it in two groups. First, the core layers. This is the agent itself, its internal workings. You have perception, the agent's senses. Takes raw input camera feed, text, sensor data, cleans it up, extracts the important features, and passes it on.
Seeing or hearing the world.
Basically.
Yeah.
Then the cognitive layer, the brain. This is where the decision-making, planning, learning happens. It processes the perceived information and decides what to do based on its goals and internal state.
The thinking part.
And the action layer. This translates the cognitive decisions into actual activity. It validates the planned actions, performs safety checks, monitors the execution, makes sure it's safe and feasible before doing it.
Okay, perceive, think, act. That makes sense for the core. What about the standard layers?
These provide the enterprise support structure around the agent. There's integration. This is the connective tissue.
That-
It lets the agent talk to external systems, databases, APIs, other enterprise applications. Manages that communication flow, often using things like RA embeddings for accessing knowledge.
Connects it to everything else.
Right, operations. This layer oversees the whole thing in real time, monitors performance, gathers feedback, manages the system, optimizes processes continuously.
Keeps it running smoothly.
And infrastructure. This is the foundation. Provides the computing power, storage, networking, often cloud-based, using GPUs for heavy lifting. Ensures the agent has the resources it needs to run reliably and scale up.
Got it. The engine room.
Pretty much. All these layers have to work together seamlessly for an effective, scalable, agentic AI application.
Okay, so we understand the agent types, the layers.
Mm-hmm.
How do you actually implement this? What tools and frameworks do people use? The playbook mentioned different categories.
Yeah, the landscape is evolving fast.
Yeah.
You've got vertically integrated platforms from vendors like Salesforce, cloud providers like AWS Bedrock offering agent services, proprietary platforms built in-house, and, importantly, a growing ecosystem of open-source frameworks.
Let's focus on the open source ones, as the playbook highlights a few key options for building custom solutions.
Good idea. The playbook dives into three popular ones: LangGraph, CrewAI, and AutoGen. Choosing between them depends heavily on your specific needs.
So what are the key things to consider when choosing?
The playbook provides a really useful comparison table, but some key factors are compatibility. Does the framework support the specific agent types you need? Reflex, goal-based, etc.
Right. Scalability. How well does it handle more agents or more complex tasks? LangGraph is good for complex stateful workflows. CrewAI is built for production-grade multi-agent collaboration, especially parallel tasks. AutoGen is maybe better for simpler multi-agent setups currently.
Integration. How easily does it connect with your existing enterprise systems? LangGraph and CrewAI leverage the LangChain ecosystem, which is pretty broad. AutoGen is more aligned with the Microsoft ecosystem right now.
Flexibility. Can you easily customize agent behaviors? LangGraph is very flexible for tailoring logic. CrewAI uses a role-based architecture that offers flexibility. AutoGen is strong for conversational agents. Learning support. Does it help agents learn and adapt? LangGraph supports stateful agents that learn. CrewAI has built-in memory functions and allows human feedback loops. AutoGen enables agents to learn collaboratively through conversation.
Observability. Can you easily track what the agents and LLMs are doing in real time? All three integrate with tools like AgentOps and Arise Phoenix. LangGraph also has deep integration with Langsmith for monitoring.
Community and support. Is there a strong community for help and resources? LangGraph has a big one via LangChain. CrewAI's is growing, boosted by partnerships. AutoGen's is maybe a bit smaller currently.
And cost effectiveness? FinOps. What's the total cost? Open source isn't free when you factor in development, hosting, and management. You need to consider the whole picture.
Okay, lots to weigh up there. It's clearly not a one-size-fits-all decision.
Not at all. Choosing the right framework is crucial for operational success, and making sure your agentic solution actually fits within your existing enterprise environment. It's a critical step for anyone building sophisticated capabilities, perhaps even aiming for something like an AI coach by Anil Nathu.
And the key takeaway from the playbook here seems to be move fast, yes, but build that foundation carefully.
Exactly. It's about sustainable, long-term advantage, not just rushing out the first thing. 3, building for the future. AgentOps lifecycle management.
Okay, building the agents, choosing the framework,
Yeah.
that's one piece. But once these intelligence systems are developed, how do you actually manage them effectively throughout their entire life? They're not static software.
Precisely. And that's where AgentOps comes into the picture. Think of it as an end-to-end lifecycle management framework specifically designed for the unique needs of agentic AI
It
systems.
was like DevOps or MLOps, but for agents.
Exactly. It builds on principles from DevSecOps, MLOps, even LLMOps, but it specifically addresses the extra complexities of agentic systems, things like their autonomous planning, reasoning, decision-making, their use of memory, their interaction with external tools and knowledge.
What's a really critical aspect of AgentOps?
Guardrails. Establishing robust guardrails is paramount. These are the constraints, the safety mechanisms, the operational boundaries that prevent unintended actions and ensure these autonomous systems stay within defined, safe limits.
Okay, so keeping them from going off the rails.
Essentially, yes. The playbook lists several key objectives for mature AgentOps adoption, ensuring the agents behave consistently, enhancing overall system reliability, speeding up issue resolution when things go wrong, maintaining compliance through clear audit trails, enabling scalable operations as demand grows, and optimizing costs.
Let's break down the AgentOps lifecycle itself. Yeah. The playbook outlines distinct phases, right? How does each one contribute?
Yes, it's a continuous cycle, much like DevOps. 1, define and design. This is where it starts. You need clear objectives. What should the agent actually do? Both functional goals and non-functional ones, like performance or security. Crucially, you have to build in safety, transparency, and accountability right from the design stage
How do you do that?
by explicitly designing for human-in-the-loop interventions, deciding where human oversight is needed, maybe even building in that big red button for immediate human override in critical scenarios. And a vital output here is the AI bill of materials.
AI bomb.
AI bomb. What's that? It's like a software bill of materials, but for AI. It catalogs all the components, the models, data sets, libraries, tools, dependencies, everything that makes up the agentic system. It provides transparency and helps with continuous risk assessment.
Okay, that sounds important for understanding what's inside.
Very. Then 2, development. This is where you integrate the LLMs, connect the data sources, build or integrate the tools the agent will use, often leveraging those frameworks like LangChain we discussed. A really critical design point here is putting strict validations on any user-provided prompts to prevent malicious inputs or unintended behaviors.
Right, guarding against prompt injection and things like that.
Exactly. Agents are also trained with specialized skills here, and the playbook mentions the reflection design pattern where the LLM is prompted to evaluate its own output, creating this loop of self-critique and improvement during development.
Interesting. Self-improvement built in.
Yes. Phase 3, testing and evaluation. This has to be rigorous. You define success metrics first. How do we know if the agent is doing a good job? Then you need a dual testing approach.
Dual approach.
Yeah, vertical testing looks at individual agent performance things like how often did it pick the right tool, how accurate was its output, how long did it take, how often did a human have to step in. And horizontal testing looks at the end-to-end system performance. How well do multiple agents collaborate? Is the overall workflow efficient? Key metrics here might include tool utilization efficacy, memory coherence, strategic planning effectiveness.
And security testing is obviously huge here.
Paramount. Mitigating risks identified by groups like OAuth for LLMs and agents, prompt injections again, data leakage, model poisoning, agents getting too much agency or capability.
Right. Then 4, deployment. Assuming it passes all the tests, you release it to production. This involves securely managing credentials for all the tools and APIs it needs access to, using things like HashiCorp Vault or cloud provider secret managers.
You also need to size the infrastructure correctly for auto-scaling, handle potentially high data volumes, ensure low latency. Often, this means deploying agents as container workloads using Kubernetes. And you set up automated deployment pipelines using infrastructure as code tools and continuous delivery strategies like blue-green or canary deployments to minimize risk during updates. Performance here is often measured using DORA metrics.
Standard modern deployment practices, basically.
Exactly, but applied to these more complex agentic systems. And finally, 5, observe and improve. This is absolutely critical and needs to be planned before you go live. You need robust frameworks for end-to-end observability, traceability, and debuggability.
Okay, let's break those 3 down.
Yeah.
Observability.
This is about getting insights into how the agent is working internally and how it's interacting with its environment. tracking inputs, outputs, the reasoning steps it took, the chain of thought, model performance, detecting anomalies, tracking integrations. For an application like the AI Coach by Anil Nathu, observability means you can understand exactly how it processed your request step by step, which is crucial if an interaction goes wrong and you need to figure out why.
Got it. Seeing inside the black box. Traceability.
This ensures transparency. It's about tracking the decision-making process and the outcomes. Having logs of why an agent made a certain decision, version control for the agent and its components, ensuring you can reproduce results. This is vital for compliance and auditing.
Being able to prove how a decision was made.
Yeah.
And debuggability.
This is all about quickly diagnosing and fixing problems when they inevitably occur in production. Having tools for refining prompts, debugging workflows step by step, analyzing logs, simulating tricky scenarios.
Finding and fixing bugs fast.
Right. And overarching all of this is continuous learning. These agents shouldn't be static. You need processes for frequently updating their knowledge bases, conducting regular performance audits, and refining their behavior based on real-world interactions and feedback.
Wow. Okay, that's a comprehensive life cycle. It definitely sounds like more than just LMOps.
Oh, much more. The Infosys Playbook has a great comparison figure showing the evolution. LMOps is primarily focused on the LLM itself, training, fine-tuning, deploying the model API, monitoring its inference.
Right, model-centric.
AgentOps has a much broader scope. It oversees the full life cycle of the entire agentic system, orchestrating complex interactions between agents, tools, external systems, dynamic environments. The integration complexity is way higher, managing fleets of agents, handling concurrency, role-based collaboration, resource conflicts.
Okay.
Evaluation is different too. LMOps cares about accurate model outputs. AgentOps needs to ensure the agent is dependable, traceable, auditable across all its operations, not just the LLM part. Observability and debugging need extra dimensions for AgentOps to capture those multi-step interactions. The agent's goals, its chain of thought, tool usage, memory access. You need to understand the autonomous decision process.
A lot more to track.
Yeah. Logging and audit trails expand to cover the agent's decisions, workflows, memory states. And lifecycle management covers the whole system: agent design, orchestration logic, tool integration, updates, cost optimization, retirement, not just the model.
It's a whole system perspective. Are there specialized tools emerging for AgentOps yet?
They are emerging, yes, but the playbook notes it's still early days. There are tools focusing on agent design, evaluation, security scanning, AI bomb generation, observability platforms like Langsmith, AgentOps.io, Arise Phoenix, and some trying to offer end-to-end capabilities, but it's still a rapidly evolving landscape.
Which means there are challenges, I assume.
Significant ones. The lack of standardized evaluation frameworks makes benchmarking hard. There isn't one widely adopted platform yet for managing the whole lifecycle, so you often have to stitch tools together. Automating AI bomb generation and compliance testing is still tricky. Real-time observability can get expensive and resource-intensive, especially for large, complex, multi-agent systems. And traceability, especially with black box LLMs and maintaining auditable agent memory, remain tough nuts to crack.
Still some work to do on the tooling and standardization front. What's the future look like for AgentOps then?
The playbook points to some exciting possibilities, things like automated design of agentic systems, where AI meta agents actually help design and refine new agents.
Whoa, AI building AI agents.
Yeah, also self-provisioning agents that can configure their own infrastructure, self-observing agents that monitor their own actions for alignment and ethics, development of standardized protocols for inter-agent communication and collaboration.
That sounds like a much more automated future for managing these systems.
It does. These innovations should streamline management and create more resilient, adaptable, and intelligent AI infrastructure. But the key message is that moving from today's experiments to that future at enterprise scale requires patience. It's about balancing innovation with responsible deployment. Investing strategically in AgentOps now, even with the current challenges, is what will position organizations to really benefit from trustworthy, enterprise-ready agents down the line.
Patience and a strong foundation.
Got it.
4. Advanced applications, agentic patterns, and future directions. Okay, let's dive even deeper now. We've talked about the building blocks, the management. Let's explore some of the more sophisticated patterns and techniques that power advanced AI agents and maybe peek at where the research is heading.
Sounds good. Because for agents to really automate complex processes, they need to be able to break down a user's request into a clear step-by-step plan.
Like solving that algebra equation you mentioned, identify, simplify, isolate, check.
Exactly. But in business scenarios, the equation is much fuzzier. The agent needs to navigate enterprise processes, understand policies, know which tools to use when. That's where these advanced patterns come in.
Okay, so what are some common patterns the Infosys playbook highlights?
They detail several really useful ones. First, the single agent with task decomposition. This became popular with the React paper Reason and Act. The LLM generates a reasoning chain, thinks through the steps, then acts by calling a tool, processes the result, the observation, and continues the cycle until the task is done.
Can you give an example?
Sure. You ask for the weather in New York for the next 4 days. The LLM thinks, I need weather data for New York, 4 days. It acts, calls a weather API tool with New York in 4 days. It observes, gets back the forecast data. It processes this and presents the answer to you. Agents can also chain tools, maybe use the weather tool, then a flight booking API if you asked about planning a trip based on weather.
And frameworks like LangChain make this easier to implement.
Yes. LangChain, Llama Index, they provide building blocks for exactly this kind of React pattern.
Okay, what's next?
Agents with external planner. Sometimes, especially for tasks needing deep enterprise-specific knowledge, a single LLM prompt isn't enough to generate the whole plan. Think of an IT ops engineer finding the root cause of a complex system failure. The LLM might not know the specific troubleshooting steps for your company's setup.
Right, it lacks that specific context.
So here, you provide the agent with an external plan, maybe retrieved from a database of standard operating procedures, or generated by querying a configuration management database, CMDB, for system dependencies. The plan guides the agent's sequence of steps.
So the plan comes from outside the LLM's immediate reasoning.
Exactly. Then you have static or graph-based agents. These are kind of semi-autonomous. They follow a predefined flow or graph structure, but they can make dynamic decisions at certain points, often using an LLM.
Okay, example.
Imagine that invoice tracking query again. The agent understands the email request. It follows a flow. Step 1, use a tool to retrieve order details. Step 2, based on the order status, product available, .shipped, delayed, the agent makes an LLM-powered decision. Maybe inform the inventory manager, or email the logistics company for an update, or just reply to the customer. The overall flow is defined, but decisions within the flow are dynamic.
And the graph structure helps manage complexity.
Yes, especially when you have multiple steps or agents. Nodes in the graph can be agents or tasks. Edges show dependencies. This allows for things like parallel execution, maybe an inventory agent and a shipment agent work simultaneously, and reallocating tasks if one step fails. This pattern is really powerful for complex RDA systems, too, where you need agents to retrieve knowledge, rewrite queries, dynamically route to different tools, even for self-reg, where an LLM critiques its own retrieval or answer.
Interesting. Graph-based flow with AI decision points.
Right. And finally, multi-agent or collaborative agents. This is where you have multiple agents explicitly working together as a team. Frameworks like MetaGPT, AutoGen, Crew AI are designed for this.
We touched on this. What are the collaboration patterns?
The playbook mentions a couple. One is the hierarchical pattern. You have a supervisor or manager agent that receives a request and delegates subtasks to specialized worker agents, like our customer service example. A supervisor agent gets the order query, routes the inventory check part to an inventory agent, routes the shipping statuses part to a logistics agent, gets the results back, and then decides how to synthesize the response or if it needs human escalation.
Like a team manager.
Exactly. The other is the conversation pattern. This is more dynamic, less centralized. Agents can communicate directly with each other, perhaps in a sequence or a more free-form way, to achieve a goal. The playbook uses an example of a knowledge publishing platform. You could have an author agent, a reviewer agent, a copywriter agent, a social media promoter agent. They might pass an article back and forth, each adding their expertise based on defined rules of interaction. Maybe a research agent finds info, the author drafts, the reviewer critiques, the author revises, the copywriter polishes, the promoter schedules posts.
Well, like a virtual content team.
Precisely. These multi-agent systems can tackle really complex, multifaceted problems.
But these advanced patterns must bring their own set of technical challenges, right?
Yeah.
Especially when you have multiple agents interacting, remembering things, running potentially long processes.
Oh, absolutely. Building and running these sophisticated systems, like a highly capable AI coach by Anil Nathu would need to be, involves overcoming several hurdles. Memory management is a big one. Agents need to store and recall conversation context, facts learned, outcomes of actions. This often involves using vector databases or caches, but designing effective mechanisms for both short-term recall within a conversation and long-term recall across interactions is really tricky.
Keeping track of everything accurately.
Right. Related to that is context management. Multi-agent chats or long single-agent interactions can generate huge amounts of text. Feeding all of that back into an LLM on every turn hits token limits, increases costs, and slows down response times. So you need smart techniques like summarizing past parts of the conversation, maybe overwriting less relevant context, or using sophisticated recall mechanisms to pull only the necessary bits from long-term memory.
Managing the context window efficiently.
Exactly. Deployment is another challenge. These multi-agent systems often involve long-running processes. They need to be deployed in a distributed way across multiple servers potentially, and they need scalable, low-latency messaging systems so agents can communicate reliably and quickly, almost like a microservices architecture.
Needs a robust infrastructure.
Definitely. Then there's replay and replan based on user inputs, that human-in-the-loop aspect again. The system needs to be flexible enough to handle a user interrupting, providing more information, or asking to redo a step. The agent needs to be able to pause, maybe roll back, incorporate the new input, and intelligently replan its course of action.
Needs to be interruptible and adaptable.
Yes. And finally, policy management. You need ways to control agent behavior, setting limits on how long an agent can run, defining the allowed order of operations, managing dependencies between agents. This is crucial to prevent infinite loops, ensure a good user experience, no waiting forever, and control computational costs. You don't want agents just chatting endlessly and racking up bills.
So setting clear rules of engagement for the agents.
Precisely. Managing these technical aspects is key to building reliable and efficient advanced agentic systems.
And beyond these engineering challenges, there's ongoing research pushing the core reasoning capabilities of these agents even further, right?
Absolutely. The playbook highlights some really exciting research directions aimed at making agents think better. One area is reasoning or search algorithms. Instead of the typical LLM approach of just predicting the next word, greedy search, researchers are using more sophisticated search algorithms like Monte Carlo tree search, depth-first search, breadth-first search. These allow the agent to explore multiple possible thought sequences or plans, evaluate them using reward models, and choose a better path. It's like enabling slow thinking versus just reacting.
So they can explore different ways to solve a problem before committing.
Exactly. This is vital for complex tasks like refactoring large code bases where the agent needs to analyze dependencies, run tests, and try different approaches, or for adapting to dynamic environments where the best plan might change.
Makes sense. What else?
Ensemble methods. This is about combining multiple models or agents to get a better result. Think of an LLM debate, where different models argue for different answers, or an agent forest, where you run multiple agents and take a majority vote. This can significantly increase the accuracy and robustness of the reasoning process.
Wisdom of the crowd, but for AIs.
Kind of, yeah. And process reward models. Traditionally, you might train a model based only on whether the final answer was right or wrong. Process reward models provide supervision at each step of the reasoning chain. This encourages the agent to follow the correct process of thinking, not just stumble upon the right answer. It's crucial for ensuring reliable reasoning in complex, multi-step tasks like root cause analysis.
Rewarding the right steps, not just the final outcome.
Exactly. These research advances are already finding their way into tools and platforms, enabling more powerful and reliable agentic systems. And the pace of innovation here is just incredible, promising even more value down the road. Navigating the future responsibly. Risks and safeguards.
Okay, this brings us to a really critical part of the discussion. We've talked about the immense power and potential of agentic AI, but as these systems gain more autonomy, especially in high-stakes areas like healthcare or finance, the question of responsibility becomes paramount.
Absolutely paramount. And the Infosys Playbook drives this point home very strongly. Responsibility must be architecturally inherent, not retrofitted. You can't just bolt on ethics at the end.
It has to be baked in from the start, foundational. This is core to any trustworthy AI deployment, including building something like the AI Coach by Anil Nathu Services.
Couldn't agree more. Agentic systems offer transformation, but they also introduce unique risks we absolutely must address proactively. The playbook details several key ones. First, reasoning limitations. Agents, especially those relying heavily on LLMs, lack deep human context, cultural understanding, historical perspective. They operate based on patterns in data and probabilistic states. This can lead to failures in nuanced situations.
Like the supply chain example.
Exactly. The agent optimized based on data but failed to account for geopolitical factors because that common sense or historical context wasn't explicitly in its model or dependency graph. The playbook references an AAI report attributing almost 60% of agent failures to this kind of mismatch between the LLM's general knowledge and the specific, often unstated requirements of the real-world domain. It highlights the brittleness when facing ambiguity.
So they can miss the bigger picture.
Sometimes, yes. Second risk, resource overuse, sometimes called the tragedy of the commons. In systems with multiple agents potentially calling shared resources like LLMs, if they aren't coordinated, they can individually optimize for their own tasks and collectively overwhelm the system.
Driving up costs and slowing everything down.
Right. The GovSim simulations mentioned showed agents often prioritizing short-term task completion, leading to resource exhaustion. This mirrors real enterprise concerns about soaring cloud costs if LLM usage isn't carefully managed. And it links to the Jevons paradox, the idea that making something more efficient, like LLM inference, can sometimes paradoxically lead to more overall consumption because it becomes cheaper and easier to use.
Huh. Efficiency leading to more usage. Interesting paradox.
It is. Third key risk, dynamic value drift. This is subtle but important. It's when an agent, optimized for a specific, perhaps short-term metric, starts to behave in ways that undermine broader, long-term goals or societal values.
Like the hospital discharge example.
That's the perfect illustration from the playbook. The algorithm successfully reduced immediate bed occupancy, the metric it was optimized for, but it did so by discharging patients too early, leading to higher readmissions later, straining overall healthcare resources, and potentially harming patient outcomes. The narrow optimization undermined the larger goal of effective healthcare.
Wow. Optimizing for the wrong thing can have serious consequences.
Very serious.
Okay, so those are some pretty significant risks. How is the industry, according to the playbook, working to address these and ensure responsible agentic AI? What are the key moves?
There are several important approaches being developed and deployed. One is argri with ethical grounding. This means going beyond just retrieving factual information. It involves embedding ethical principles or guidelines directly into the retrieval augmented generation process.
How does that work in practice?
For instance, a medical orgri system wouldn't just pull up diagnoses. It might be designed to explicitly cross-reference potential diagnoses against principles of patient autonomy or check recommendations against the latest peer-reviewed ethical guidelines for that condition. It bakes ethics into the knowledge retrieval and generation process. Anthropic's constitutional AI is an example of this direction.
So, building ethical checks into the information flow.
Exactly. Another technique is probabilistic belief state tracking. This helps agents manage uncertainty more effectively. Instead of assuming they know things for sure, they maintain probabilities about the state of the world and update them dynamically. IBM's Neurosymbolic Advisor for Fraud Detection is cited. It uses this to combine logical rules with uncertain data, reducing false positives significantly by better handling ambiguity.
Managing uncertainty better. Makes sense.
Then, human-AI arbitration protocols. We keep coming back to this, but it's crucial. Designing clear protocols for how and when humans intervene or oversee agent decisions, especially in high-stakes scenarios. The playbook mentions the autonomy dial concept used in some banking fraud systems.
The autonomy dial.
Yeah, the system might handle routine, low-risk cases autonomously, but as uncertainty or risk increases, based on its belief state tracking perhaps, it dials down its autonomy and escalates the case to a human operator. This balances efficiency with safety, significantly reducing false positives in the fraud example. It highlights that collaboration, not just full autonomy, is often the goal.
Finding the right level of human oversight.
Precisely. And finally, using APIs as governance mechanisms. APIs aren't just for integration. They can be powerful tools for enforcing permissioned autonomy. You can restrict agents, ensuring they can only access vetted tools, specific data sources, or execute certain types of actions via controlled APIs. They act as gatekeepers.
Controlling what the agent is allowed to do.
Exactly. It enforces boundaries, enhances security, and makes the system more modular and manageable.
Okay, those are good technical and procedural safeguards. What about higher-level evaluation and governance frameworks?
Also critical. The playbook highlights two key types: evaluation frameworks. Going beyond simple accuracy metrics, the playbook introduces a specific one called the Socio-Technical Evaluation Matrix, STEM, It assesses agentic systems not just on technical performance, like task completion rate or efficiency, but also on their societal impact.
How does STEM do that?
It evaluates dimensions like ethical alignment. Does the agent adhere to ethical principles? Cross-cultural adaptability. Does it handle different cultural contexts appropriately? Adversarial robustness. How well does it resist malicious attacks? Explainability under uncertainty. Safety and multi-agent coordination. Swarm safety. And even energy equity trade-offs. It forces a much broader, more holistic evaluation.
It sounds much more comprehensive than just technical benchmarks.
It is. And then governance frameworks. These are the broader rules and regulations. The EU's Digital Services Act, DSA, is mentioned, which mandates things like socio-technical stress tests for large AI systems, simulating ethical dilemmas to see how they respond. Another example is federated fairness audits, championed by the Responsible AI Consortium, where organizations collaborate across industries to benchmark and reduce biases in AI systems like hiring algorithms.
So both internal evaluation and external governance are needed.
Absolutely. Though the playbook also notes challenges here, like jurisdictional conflicts, different countries having different rules, like data localization laws that can complicate global governance efforts.
Right, it's a global challenge. So even with these moves and frameworks, what are the big remaining gaps and emerging threats that we still need to really grapple with?
The playbook flags several critical ongoing challenges. The belief system deficit. We touched on this. Agents still lack that deep, layered human understanding, incorporating cultural norms, history, complex social dynamics. The refugee resettlement agent example is stark. Technically, it found housing, but failed to consider social cohesion factors because it couldn't model community dynamics. Research into things like neuromorphic architectures is trying to bridge this gap.
The gap between probabilistic reasoning and true understanding?
Yes. Then the autonomy accountability paradox. As agents become more autonomous, who is responsible when things go wrong? Pinpointing accountability becomes incredibly complex. Gartner's prediction that 25% of enterprise breaches by 2028 will stem from AI agent misuse is sobering. Solutions being explored include blockchain for immutable audit trails and specialized auditing agents.
The accountability gap is huge.
It is. Environment sustainability is another growing concern. Agentic systems often make many LLM calls, which is computationally intensive and consumes significant energy. We talked about the Jevons paradox. A key solution here is the shift towards smaller, domain-specific models, SLMs, instead of always using giant general-purpose LLMs. Infosys themselves have pioneered this, achieving significant energy reductions up to 48% in inference energy by using optimized SLMs. Pairing these with energy-efficient hardware and green data centers is crucial.
Using the right size model for the job and efficient infrastructure.
Exactly. And finally, the tension between explainability versus performance. The very modularity that makes agentic systems powerful networks of specialized agents can also make their overall decision-making process opaque. How do you explain why a system of agents arrived at a decision?
Yeah, it's not just one model anymore.
Right. The playbook discusses various approaches to embed explainability into the orchestration layer itself, techniques that try to decouple execution from explanation, use attention maps, identify key concepts driving decisions, concept bottleneck models, or chain interpretable modules together. It's an active area of research and development.
Making the why clearer even in complex systems.
That's the goal. But the overarching message here, echoing that Tree AAI report, is stark. Responsibility cannot be an afterthought. It demands a collaborative, multidisciplinary effort involving cognitive scientists, ethicists, economists, policymakers, engineers, everyone. It's about embedding ethical considerations deeply into the architecture and aligning that incredible machine efficiency with human wisdom and societal values.
A profound challenge, but absolutely necessary if these agents are to be forces for good. 6. Action plan and conclusion. Okay. We have covered an enormous amount of ground today, from the fundamentals of agentic AI through the architecture, the management with AgentOps, advanced patterns, and right into those critical responsible AI considerations. It's been a real deep dive.
It certainly has. There's a lot to digest.
So for you, our listener, sitting there thinking, okay, this is powerful, potentially transformative. What do I do now? How do I start applying these insights in my own context? Let's try to distill this into a practical action plan. Think of this as your guide, drawing on all these insights from the Infosys Playbook, relevant for anyone considering this journey, perhaps even those aspiring to build something like an AI coach by Anil Nathu.
Sounds like a good way to wrap up. Here's a concise action plan, breaking it down into key steps. 1. Strategic adoption first. Don't lead with the technology. Start by deeply understanding agentic AI's transformative potential, specifically for your industry and business. Look for areas where you can truly reinvent a process or create a new capability, not just make incremental improvements.
Hmm?
And think about adopting a flexible poly AI and poly agent architecture from the start. Don't lock yourself into one approach too early.
Focus on reinvention, stay agile.
Got it, too.
Assess suitability rigorously. Before you commit resources, use that scope framework. We discuss strategic alignment, complexity, operational environment, performance requirements, ethical security constraints. Be honest about whether agentic AI is genuinely the best tool for the specific challenge you're targeting. Not every problem needs an agent.
Choose your battles wisely. 3. Design with purpose and safety. When you do proceed, define crystal clear objectives. What must the agent achieve? What are the constraints? Build in safety, transparency, and accountability from day one. That means designing for human-in-the-loop interventions where needed, having override mechanisms, and starting to generate that AI bomb, AI bill of materials, early for transparency.
Safety and transparency baked in, not bolted on.
4. Embrace AgentOps for lifecycle management. Don't treat this like a typical software project. Adopt a systematic AgentOps framework to manage the entire lifecycle. That includes rigorous design, secure development practices like prompt validation and reflection patterns, comprehensive vertical and horizontal testing, robust deployment strategies, and critically continuous observability, traceability, and improvement mechanisms post-launch. Understand how this differs from and expands upon LLMOps.
Manage the whole life cycle systematically.
5. Choose the right tools and architectures. Select the appropriate agent types for the task's complexity. Decide thoughtfully between single-agent and multi-agent architectures, probably leaning towards multi-agent for complex, collaborative enterprise tasks. And carefully evaluate those open-source frameworks, LangGraph, CrewAI, AutoGen, etc., based on compatibility, scalability, integration needs, flexibility, learning support, observability, and cost.
Match the tools to the specific job.
6. Prioritize responsible AI, the core principle. This cannot be stressed enough. Ensure responsibility is architecturally inherent. Implement techniques like R with ethical grounding and probabilistic belief state tracking to build trustworthy decision-making. Establish clear human-AI arbitration protocols and consider that autonomy dial concept. Leverage APIs as governance mechanisms to enforce permissioned autonomy. Use advanced evaluation frameworks like STEM to assess both technical performance and societal impact, including ethics and sustainability.
Responsibility woven throughout the architecture.
7. Address technical challenges proactively. Don't wait for problems to emerge. Actively design solutions for those known challenges. Memory and context management for long interactions, scalable distributed deployment, robust user replan capabilities for human interaction, and clear policy management to guide agent behavior and control costs.
Anticipate and design for the tricky bits.
And finally, 8. Innovate sustainably. Be mindful of the environmental footprint. Actively consider using smaller domain-specific models, SLMs, where appropriate, rather than defaulting to the largest general-purpose LLMs. Pair these with energy-efficient hardware and green data center practices to mitigate the computational intensity and address potential Jevons paradox effects.
Build smart and build green. That's a fantastic, actionable list. This deep dive has really shown that agentic AI isn't just the next tech buzzword. It's a strategic shift.
It truly is.
It demands not just technological skill, but a really thoughtful, strategic, and deeply responsible approach to implementation. It's about moving intelligently, building that strong, sustainable foundation for the incredibly intelligent systems that are coming our way.
Well said. And as the Infosys Playbook concludes, by enabling machines to think, learn, and act with increasing independence, we're not just enhancing AI's capabilities, we're fundamentally redefining the relationship between humans and technology. The future powered by agentic AI promises to be more dynamic, intelligent, and impactful than ever before. The journey requires patience, iteration, continuous refinement, but the potential long-term benefits of trustworthy, adaptable, enterprise-ready agents are simply immense.
An exciting, if challenging, road ahead.
Thank you for joining us today. Visit the AI Coach website for more AI insights.